So here's our perpendicular bisector theorem. This is telling us that if our point is on the perpendicular bisector, so point P, then it's going to be equidistant from these points at the end, A and B, which is why we have those marked congruent. It also is going to tell us that these segments up here in blue, so CA and CB, are congruent as well. So we learn quite a bit about a triangle if we know that we have a perpendicular bisector. That's our theorem. Here are the examples we looked at in class. You can see on this first one we have SP marked as 6.8. Because it's a perpendicular bisector, that tells us that PS is going to equal 6.8 as well. Because remember, those two segments are going to be congruent. So let's look at another example here. We're asked here to solve for YZ, which you can see is given as n plus 17. And then we're also given the length of that other segment as 4n minus 13. So because of our theorem, I can say that n plus 17 equals 4n minus 13. Okay? Because I know it's perpendicular bisector, I know that they're congruent sides. So to solve for n, I'm going to go ahead and start by moving this 13 on over. I'll add it to both sides. That's going to give me 30. N plus 30 over here equals 4n. Then I got to get my n's together, so I'll say minus n minus n. That's going to get me to 30 equals 3n. Now I'm down to my single step. I'm going to go ahead and divide that by 3 and find that n equals 10. Awesome. So if I'm going to plug that in here, check my answer. Oh no! What did I do wrong? So remember, what we're looking for is the length of that segment, which is given as n plus 17. So I have to substitute this 10 back in for n. So my real answer is going to be 10 plus 17, which is 27. So if I go, I'm going to plug that in. All right, my answer is actually going to be 27. Let's check that. Ta-da! So that's an example of how you would use this theorem to solve for the length of a side. We also talked about the angle bisector theorem, which is similar, except it's not making any right angles for us, okay? So that's the converse. We haven't talked about that quite yet. So an angle bisector is going to cut an angle into two equal parts. So if I look at some examples that can help me think about this, in this case I'm looking for angle GFJ, okay? Well, I'm given the other half, see, 42. I know that this angle's cut in half, so if it's 42 on that side, they're both going to be 42. And in a lot of ways, that theorem's a little easier to work with.